Hi guys, and welcome back to part 2. In the first part, my computer just crashed, so I had to just split the two videos into two. So I'll start off where I left off, where we're going to create, where I was going to write some code. And I've written the code to save time, and all these files from these exercises will be available as a separate download in a packaged file container, and it will contain all the files that I'm doing in the exercise. So I'm just doing this to save time. So what we're going to do, we create a folder. You can create a folder in as you like, as how you like to work, and just put this file in that folder that you're working in your current working environment. I can see, I think I'll do that also myself. You will file this in the Lendy folder. Just copy this file to your working folder. I cleaned up all the earlier code in the archived folder. If you want to do that way, you can also do that. So this is the file that we have created, and I'll explain in a minute what I'm going to do, what the code does. What it does is just creates a database for our project, for our LendyDB. Let's just call that LendyDB application. Let's run this code. So make sure it prints out something like the same as here. And also check your inspect the contents of your folder where you are working, and you should see 3 sets of 3 files, 1 set per entity with extension of .back. We have 1, 2, 3 of back. Let's 3 sets of back. See 3 sets of dot files and 3 sets of dir files. 1 set of 3 files, I mean. So what is this file? What is this program doing? We started off by importing the dbm module. The module internally analyzes your system to determine which DBM library is available and it initializes it for use. You then create the raw data items by extracting the values from the Excel spreadsheet, or you just type them in manually, like I did. Note that you changed the item description field so that it now records what kind of item you have. Tool, book, DVD, and so on. What you can do whichever item you want. You could have created an extra field instead of, and that would have been equally valid. But for this exercise, we choose to reuse the existing field name. We then define the create DB function, which opens the DBM database file in C for create mode. The C mode creates a new file if one does not exist, or opens the existing file if it has already been created. You then use a for loop to read each data item and store it in the database using the first field as the key and joining all the fields as a comma separate a string for the value. And we use the try finally construct to ensure all data was written to the file and it was closed properly. The readDB function is converse operation to create DB. It opens the file using R for read mode and then returns the contents as a list using a list comprehension. If you expected the database to be very large, you could have made this function into a generator instead and yielded each line in turn. Because you don't expect the lending library to contain a vast number of items or members, returning a list is fine. And finally, the main function calls the createDB function once for each data entity. Note that you do not provide any file extension. DBM does that itself. Main then checks that the data has been created correctly by printing the output from readDB for each database. The databases created by DBM consists of 3 files. One file contains the actual data. The other 2 files hold the index information that DBM uses to find the records in the data file. It is this indexing mechanism that makes DBM so much faster than simply searching sequentially through a plain text file. You should not try to edit the DBM files directly. Okay guys, welcome back. Now I'll put the code here. And just one thing that you need to do before you execute this file that is included in the package that I have provided as a download is just changed under readDB. Just change it says R in that file, but change it to C. Otherwise, it won't work. So we replicate in this code, we replicate the functionality of the DBM example, but use the shell instead. The code is simpler as a result. So let's just try to run it. So check that your output is similar to this. Fortunately, I don't have a version to, I haven't found a way to make it fit, all the code fit into the window instead of have to scrolling it all the way over there. So if you just use the file that I've provided, it should produce the same output. So how this code works is that the file is very similar to the one using DBM. We start off by importing shell instead of DBM. The 3 sets of data definitions that follow are identical to the earlier example. We then define the 2 functions, createDB and readDB. This is where the shell version starts to simplify the code. For creation, the shelf is open and the data is written to the shelf directly instead of having to use a string join method. For reading, things are almost identical, but we use a list comprehension to retrieve, store, and return the shelf content. And the main function is also very similar to the DBM example, except for a few tweaks to the printed messages. And at this stage, the shell solution doesn't seem to have been a huge advantage. However, when you start to access the database and modify it, the situation begins to improve. You open the 3 shells and repeat the exercises from the DBM section, but this time you don't need to split the values to get a list, and you do not need to mess with the decode to get get from bytes to normal strings, and this makes the code shorter and easier to read. If the records had contained mixed types, the savings would have been even more obvious. And finally, we create a new lone record. Again, this does not require any decoding or joining of strings. When we close the shelf, we ensure that data is written to disk. So now we've seen the various options Python offers for storing objects and retrieving them. The shell module in particular offers a persistence mechanism that is compact, fairly fast, and simple to use. If you have a solution that uses Python dictionaries in memory, switching to a shell solution is almost a trivial task. However, this is still a long way short of what is needed for complex data handling. Operations like finding a set of records based on non-key values or sorting the data essentially still require a complete read of the data into memory. The only way to avoid that is to move to a full-blown database solution. However, before we look at that, we should consider some aids that Python provides to make data analysis of in-memory data sets easier. So in the next lesson, we are going to talk about how to analyze data with Python. So I see you in the next lesson.